Welcome everybody. Now I shall discuss a problem, very important problem on electrostatics. It will give you an exposure to how to solve a problem independently in the exam. Let us discuss. The question is, a charge Q is imparted to two identical capacitors connected in parallel. The separation of the plates in each capacitor is d0. Suddenly, the first plate of first capacitor and second plate of second capacitor start moving to the left with speed v. Find the current in the circuit as the plates move. Now, these are two identical capacitors, means having same capacitance initially, same plate area and same separation, same dielectric medium, that is air. Now this is the first plate and this is the second plate. The first plate of the first capacitor starts moving at a speed v, and second plate of second capacitor also simultaneously move at same speed. Now it is asked how to find out a current that flows in the circuit. So how do we expect that the current will flow? How? Now initially the charges given to this capacitor is capital Q. Now charge is distributed, but when the first plate or the plates of the capacitor move, the capacitance changes. Now, when the first plate of first capacitor moves to the left, the separation increases, thereby the capacitance decreases. First capacitance decreases. Similarly, when the second plate of the second capacitor moves to the left, the separation between the two plates decreases, thereby increasing the capacitance. So the first plate capacitance due to increasing distance decreases, and the second capacitance increases. Now what happens? There will be redistribution of charges. Since they are connected parallel, the potential is same. As you know, C equal to Q by V. Since potential in both the cases same, as first capacitance is increased, first capacitance separation increases, capacitance decreases, it will hold less amount of charge. And similarly, in the case of second capacitance, when the plate separation decreases, the capacitance increases, and since potential constant, it will hold more amount of charges. So charge will flow from the first capacitor to second capacitor from their initial values. Let us start an expression for the current. Now let Q1 as a function of time be the charge on capacitance C1, and Q2, that is as a function of time, with the charge on capacitance C2. That is, Q1 is the charge at any instant of time on capacitance C1, and Q2 is the charge at any instant of time at the same instant on the capacitance C2. Initially we know the total charge, as you know, it is conserved. So Q1 plus Q2 equal to Q. That is the total charge imparted to the system of the capacitors. Now, the capacitance of the first capacitance at the moment time t is epsilon 0a by separation. Instead of separation d0 between the plates, as in a time t, this plate has moved a distance vt, so the separation will be d0 plus vt. This is how capacitance decreases, is equal to, this is the capacitance at an instant of time t, it is equal to Q1 by V. Similarly, for second, the capacitance is epsilon 0A, and it is d0, separation decreases, d0 minus Vt, Q2 by V. Now Q1 by Q2 is equal to Q1 by V divided by Q2 by V is epsilon 0A by d0 plus Vt by epsilon 0A d0 minus Vt. Now on simplification we have Q1 by Q2 as equal to epsilon 0A B d0 plus Vt into d0 minus Vt by epsilon 0A, that is d0 minus Vt by d0 plus Vt. Now Q1 plus, adding plus 1, Q1 plus Q2 by Q2 is equal to d0 minus Vt plus d0 Vt by d0 plus Vt. Q1 plus Q2, when you add 1 plus 1, Q1 plus Q2 by Q2, d0 minus Vt plus d0 plus Vt by d0 plus Vt. As a result, Q2 as a function of time in terms of total charge is Q. Q equal to capital Q d0 plus Vt by 2d0. Similarly, Q1 as a function of time, Q1 as a function of time is capital Q minus Q2t, that is Q d0 plus Vt by 2d0, or Q 2d0 minus d0 minus Vt by 2d0, or Q d0 minus Vt by 2d0. So what we have now, Q1 equal to Q by 2 d0 d0 minus Vt and Q2 is equal to Q by 2 d0, Q by 2 d0 into d0 plus Vt. This is the expression for the charge, instantaneous charge, in terms of total charge Q, initial separation between the plates d0 and velocity of the plates. Now differentiating Q1, say I1 equal to dQ1 by dt. This is constant and d0 is constant, so it is equal to minus d, equation 1. Similarly, if you differentiate the expression for the instantaneous charge Q2, I2 is equal to dQ2 by dt, dQ2 by dt, that is Q upon 2d0 and plus d. See, the expression for current I1 is same as expression for current I2 but with a negative sign, that is I1 equal to minus I2. So negative sign shows that the expression for current I1, the negative sign shows that since the charge is decreasing, that is the current comes out of the capacitance C1, and for C2, this is the C1 and this is C2, and for C2 the current is plus I2, that is the current is flowing towards the capacitors, that is a charging current flows for the capacitor C2 and a discharging current flows for the capacitor C1. So this is how we can try a problem, and it's a very conceptual problem. I hope this problem will benefit, the explanation will benefit the students appearing the Neet examination and JEE examination. Thank you.